All right, hey everyone, what we're going to talk about today are solving quadratic inequalities. So there's some steps and some things you need to think about while you're doing that. The first step is to find the solutions by any method of your choice. So we're just going to either solve for it, factor, whatever you need to do to get your final answer to it. And then just pretend like the inequality is an equal sign while you're doing that, and then just make sure you put the inequality back in at the end. So you're going to draw a number line using whatever your solutions are. Now, you need to determine, is it going to be open or closed circles? So an open circle means it includes that point. So open would be this, and a closed would be filled in. So open, an example would be less than or greater than. Closed would be less than or equal to or greater than and equal to. All right, then what you're going to do is you're going to test a point in each interval. So as you're looking at each interval, you're going to determine, is it a true statement or a false statement? And then once you determine if it's true or false, you're going to shade the intervals that are true. And then finally, write your answer as an inequality or using interval notation. So let's get, oh, and another thing, make sure you put this in there. Your intervals, when you're doing your interval notation, if it's a closed point, you're going to use brackets around whatever is included. And if it's open, you'll use your parentheses. All right, so now let's get into it. So I've already solved this and I've done all the graphing, but I'm going to show you what I did. So first off, we have x squared minus 4x is less than or equal to 0. So right now, we're just going to pretend that's an equal sign for now, and we're going to solve it. Now, I'm going to solve this by factoring out. You've got your GCF. So we're going to factor out x, and then we're left with x minus 4. And remember, we're going to set each part equal to 0. So we're going to do x equals 0, then we're going to do x minus 4 equals 0. So you're going to add 4 to both sides, and that's where we get this. So these are going to help us determine the intervals. So I've got my number line down here, and it's solid because you've got this equal part here. So I've got a solid line here for this interval at 0, and then I've got another solid line here at 4. So now we're going to test a point in each interval. So what I did on this side of the number line is I'm going to test -1. So I'm going to take your original and I'm going to substitute in -1 wherever I see x. Oops, forgot the square there. Okay, so remember -1 times -1 gives you +1, -4 times 1 is positive, and then when you get it, you're going to get 5 is less than or equal to 0. Well, that's not true. So this one, we would not shade in this section. We would definitely shade in a different section. So now I'm going to try an interval in the middle, and I'm going to use +1 for x. And when you do that, you're going to get -3 is less than or equal to 0. Well, that's true. So now I'm going to shade in this area, but now we need to determine if we shade here. So I'm going to plug in 5, and then wherever x is, and you're going to end up with 5 is less than or equal to 0. Well, that's not true. So we're only going to shade in this middle section, and then since we have this less than or equal to sign, you need closed points, and we're going to do whatever is within that interval. So your final answer as an inequality with 0 is here, and we're saying x is anywhere in this range, including 0 or 4. So this is your interval, or your inequality. This here is your interval notation. So interval, we're going to use a bracket since it's closed. And we said it's between 0 and 4. So we do 0, 4. And since this is closed, we'll use a bracket. So this is your interval, and this is your inequality. All right, and so these would be your final answers, and this is what your graph looks like. All right, so let's go ahead, let's test number 2. We're going to go ahead and solve that. So again, we're going to pretend this is an equal sign when we solve this. And we're going to, oops, let me put that there. Okay, so now we're going to go ahead, and this is a difference of squares. So we're going to break that up into those two. So we've got x minus 1, x plus 1, and it's equal to 0. So we're setting this equal to 0, and then this equal to 0 and solve. So you're going to get x equals -1 and x equals +1. So we know when we do our number line, since it's only greater than, we're going to do a dashed section, meaning it does not include those points. So 1 and -1. And then now we're going to do our test. So let's do some test points. So in this section, I'm going to test -2 into here. And when you do that, you're going to get 3 is greater than 0. Well, that is true. So I'm definitely going to shade in this area. And it's going to be an open, since there's no line in there and it's dashed, that's why it's there. And now let's check the middle section. So I'm going to do a test point of 0. So I'm going to plug in 0 here, and I'm going to get -1 is less than or equal to 0. Well, that's not true. So since that's not true, we're not going to shade here. And then lastly, we're going to pick this interval, or this section, and we're going to substitute in 2. And you can pick any point that's in that section. I just picked the smaller number that's easy to work with. So I got 3 is greater than or equal to 0. Well, that's true. So you're going to go ahead and you're going to shade in this section. So remember, these are open because there's no equal part to it. All right, so now let's go ahead and let's write an inequality. So your inequality says that x is going to be less than or equal to -1, or x is going to be greater than 1. The interval would be, since this is going to -infinity, you've got parentheses, -infinity, comma, -1, and you want parentheses because it's open. And infinity and -infinity are always going to have parentheses. And we're going to do this. This is union, meaning it's either or it's or. And then now, look here, since this is open, we want a parenthesis, and then it's going to infinity, which is out that way. So these inequality interval notation. All right, for number 3, this is kind of the same thing as far as solving it. I factored in this. I set them both equal to 0. So I got x plus 7 equals 0, x plus 2 equals 0. So I've got x equals -7 and x equals -2. So when I factor that, I know that this part is going to be an open because there's no line underneath there. And I know this one's going to be open and dashed because there's no line there. So now we just have to determine which intervals do we shade in. So I'm going to pick a test point of -8, and I'm going to plug it in to your x's up here. So I've got So I've got -8 squared plus 9 times -8 plus 14. 0, and when I do that, I'm going to get 6 is greater than 0. Well, that is true. So we're going to shade over here. We're going to go this direction, and it's open. All right, so now let's test in the middle. So I'm going to try -3. And again, you could have picked any number. You could have picked -6, -5, -4, -3, any number in the middle. I just picked -3. And so I got -4 is greater than 0. Well, that's not true, so we're not going to shade there. And then now let's come over here. We can do any point on this side. Well, I'm going to pick a positive number just to make it easy. We could have done 0. It doesn't matter. We could do whatever point as long as it's not -2. So when I did this, I got 6 is greater than 0. Well, that's true. So we're going to shade over here. And then remember, these are both open points. And since those are open, we're going to use parentheses. All right, so this is going from negative infinity to -7, parentheses. And then we're saying or, it's going to be -2, which is open, so we do parentheses, all the way to positive infinity. All right, and then, or you could do those as your inequalities. All right, let's do, these are the answers to number 4. I want you to try number 4. And I want you to try number 5. And these are the answers. Check your answers in your work. And we're going to do number 6 together. All right, number 6 is a different one because first off, we're going to try to get it all equal to 0 when we solve this. So we're going to put this, make that equal to 0. And all I did was I moved all this over to the other side by subtracting 3x squared and subtracting 2. That cancels out, so now I'm left with 0, and I've got x squared minus 2x plus 1, and we can say it equals 0. So we're going to set this x minus 1 equals 0, and x minus 1 equals 0. So you're going to get positive 1 for both of them. So there's not really any other, it's just here. So we're just going to pick, oh, sorry, to be here. So we're going to pick a point on this side and a point on this side and determine, okay, well, if I substitute in 0, what's going to happen? Well, if I put 0 here and 0 here, I'm going to get 0. Oops, where'd my thing go? Oh, there it is. There it goes. All right. All right. So when I plug in 0, I'm going to get 1 is greater than or equal to 0. Well, that's true. So I'm going to shade here. All right. And then we already know x is 1, so, or we already have our line right here. So now we're going to check over here, which is 2. So we're going to substitute in 2 wherever we see x. And I have 1 is greater than or equal to 0, which is also true. So that means it's going to be all of this. And your line is all the numbers. So to write this as an inequality is going from negative infinity to positive infinity. So we're going to say x like that. So x is in the middle between negative and positive infinity. Or if you're doing interval, we just say negative infinity to positive infinity. So this one was kind of a different one because when you tested your intervals here, so when we test here and we test here, it was all of it. So we know your line is going to go on and on to infinity, both directions. All right, so what we did here was we did solving quadratic inequalities. So find the solution, draw a number line, test your points, shade the intervals that are true, and then write your answer at the end.